Hi everyone. So let's see how to solve this problem today. So the problem is reach end of array with maximum score. Okay, so let's go through the question description once. So you are given an integer array nums of length n. Okay, your goal is to start at index 0 and reach index n minus 1. So we have to reach the last index in the array. You can only jump to indices greater than your current index. Okay, so this just means that we can only jump forward. So suppose if we were at index 1, we can only make a jump to 2, 3, 4, 5. So basically indices greater than this 1. Okay, so we can only jump forward. Then the score for a jump from index I to j is calculated as j minus I into nums of I. Okay, so for a jump, so let's say you are making a jump from 1 to 5. Okay, so your what will be your score for this jump? So your score for a jump from 1 to 5 will be nums of 1. So whatever the value is at index 1 into 5 minus 1. Okay, so this will be your answer for this jump if you decide to make a jump from 1 to 5. Then the last line is saying return the maximum possible total score by the time you reach the last index. So we have to make jumps and we have to accumulate the scores of all the jump, and in the end we need to maximize the total score. Okay, so that's what the question is asking us. So let's go through this example. So this example is like 1, 3, 1, 5. In this, they have said like first jump to index 1. So we start from index 0. We make a jump to index 1. So what will be my score for this jump? Will be nums of 0, nums of 0 into 1 minus 0. Okay. So this will be 1 into 1 only. So then from index 1, from 3, I will make a jump to the last index. Okay, so I will make a jump from 3 to 5. So what will be my score for this jump? So this will be nums of 1, which is just 3, then multiplied with 1, 2, 3. So nums of 1 into 3 minus 1. Okay, so this will be 3 into 2, which is basically 6. Okay, so these both values will be added, the scores will be added, and then the result will be 7. Okay, so when I was going through this question, so first approach which was coming to my mind was for DP. What I'll do is I'll just try to from the first index, we start from the zeroth index. Then I try to make every possible choice. Like I will try to make a jump from 0 to 1, 0 to 2, 0 to 3, 0 to 4. And then from this 2, I'll try to make a jump from 3 to 4 to 5. Okay. So I was thinking in that way, like to recursively like call the function and to get a maximum result, and then I would have memorized it, but then it would have led to a time complexity of O of n square. But if we go ahead and see the constraints of the problem, so the constraints of the problem are telling us like the nums dot length is up to 10 to the power 5. Okay, so the length is 10 to the power 5, so we cannot afford to go over a time complexity of O of n square. We need to do this in at max of O of n log n or O of n. Like so we can go till n log n maximum. We can not go beyond that. Okay. So then I was going through this test cases and I realized one thing. Also, like the equation which is given to us is nums of I into j minus I. Okay. So let's take an example. Like suppose you are given an array on which at zeroth index there is a 4. Okay, and then there are some indices in between, and the last is at 20th index, the value is, let's suppose, 3. Okay, so when will you make a jump? That we need to figure out, like when can we make a jump possibly? Okay, so if you look at this equation nums of I into j minus I, so we need to maximize this. Okay, so we need to maximize this. So how can we maximize this? That like when we have a large nums of I multiplied with a large range. So suppose I have a 4 over here. When this 4 will be multiplied this large range, so my answer will increase. Okay, so let's say if I decide to make a jump, if there was a value like 3 over here at some 7 index, let's say. So will I make a jump over here or not? Okay, so I don't think I'll make a jump over here. I'll tell you why. Okay, so currently I am at nums of 0. Okay, so if I decide to make a jump to this 3, okay, so what will happen is that then this 3, if suppose if later I decide like I'll multiply this 3 with this whole range, so isn't it better if I would have just been on this 4 and this 4 would have been multiplied over this long range instead of this 3 getting multiplied with this long range? Okay, because if this 4 will be multiplied with the long range, this will give us a bigger value, and when this 3 will be multiplied with the long range, this will result in a relatively smaller value. So I don't think like we need to make a jump to a small index, because when a larger value multiplied with the larger range, this will give us a larger result, a larger score to be accurate. Okay, so if we have a smaller value in between, we don't need to make a jump for it. Okay, but suppose if we had a value greater than this. Okay, so if we have a value like 5, okay, at some 7 index, okay, then should I make a jump, or should I just let 4 be multiplied with this long range? So what should I do in this case? So I think I should make a jump. Okay, why I am saying is that let's see what the equation is like. If we multiplied 4, okay, 4 can be multiplied with 20. If suppose if I don't make a jump from this 4 to this 5, and I say I will make a jump only till the last of the position. Okay, so what I'll be doing is I will be multiplying this 4 with this whole range. Okay, so this will be 20. 20 minus 0 is 20. Okay, so this 4 will be multiplied by 20. But suppose if I make a jump from this 4 to 5, what I'll be saying that this 4 will be multiplying with 7, and then I will be adding a score of 5 multiplied by 13, because this 20, this 20 minus 7 will be 13. Okay, so which of this is a greater value? Okay, which of this is a greater value? So if I write this 4 into 20 as let's say if I write this as 4 into 7 plus 4 into 13. I can write it like this. 4 into 20 can be written like this. So now this 4 into 7 can be cancelled from both sides. So one is 4 into 13, one is 5 into 13. So basically, if I make a jump from over here, this 5 will be multiplied. This 5 is a larger value, and this larger value will be multiplied with the rest of the range, which will in turn give me a greater score. Okay, so I will make a jump over here because this 5 into 13 is greater than this 4 into 13. So yeah, so we can make this jump. And the third case is just that if suppose the value was not larger or not even smaller. So if the value was 4 only, okay. So if the value would have been 4, okay, and at 7 lakhs, so then it does not matter if we make a jump or if we don't make a jump, the result won't change. Why is that? Suppose if you multiply 4 into 20, if you don't make a jump from this 4 to this 4, and you directly say I'll multiply this 4 with this whole range, then this 4 is multiplied over a whole range, and this is 4 into 20. But suppose if you say I'll make a jump from this 4 to this 4, then what will happen is that this 4 will be multiplied with 7, and then plus, then let's say I say this 4 I am making a jump from over here to here, and then this 4 will be multiplied over the rest of the range. So what this will give me is 4 into 13. Okay, so if I take 4 common from this, then this is 7 plus 13, which is also 4 into 20. Okay, so both are same only. Both do not have any difference. So if we make a jump or if we don't make a jump, things won't matter because the score will remain the same. Okay, so I think yeah, we can solve it in this way because we'll be just iterating over once over the array, and the time complexity will be O of n. Yeah, so this is the greedy way of doing it. So let's go through the code now. So in the code, I have also done the same thing only, whatever have explained in the video. So in this code, I am just taking a variable result, which will be accumulating all the scores for all the jumps. Then I have initialized a variable last index. So this last index will be just storing on what value I was at previously. So in the beginning, it will be at 0, and then I'll be iterating over all the indexes and seeing why, like, what was my last index, and like whether this index value is greater than my last index value or not. Okay, so I am iterating over all the values inside this list, and I'm seeing if the current value is greater than my last index value, then I'm just accumulating it in my result with the score formula which is given in the question. So last value into I minus last index. So this I have done, and then I have just changed the last index to the current index, because after the jump I will be at the new index. Okay, so that's why I have done it. So this is how I'm iterating in the loop, and after that I have written a separate result plus equals to this, because suppose if in the case like this, if you take a case like this, in this case, this 4, I will be at this 4 in the beginning. So this 4 will be looking for a greater value. So this won't find a greater value over here, over here, over here, over here. So this won't find a greater value over here. But in the end, we need to make at least one jump to be at the final position. Okay, because we need to reach the end. Okay, so that's why if I have not found a greater value, I am just I am just multiplying this last value, which is this 4, into this with nums dot size minus 1, basically the last index minus the position where I was making a jump from. Okay, so this range I am taking and I'm multiplying the last value with it. So basically, it's for the cases where I won't be able to make a jump till the last index. Okay, so I am adding a extra result value over here to accommodate that case, and in the end, I'm just returning the result. Okay. So yeah, that's about it. I hope I was able to make you understand the whole logic for the question, and I was able to make you understand the code. So yeah, that's about it. Thanks.